so now we say science time. Everyone say it.
Science
time.
time.
Science time. Good. Okay, good. We're talking about mechanical waves. So, wait, we shouldn't begin a sentence with the word so. That's not how we do things.
Gosh.
Let me start again. We're talking about mechanical waves. And the objective is that we're going to relate the medium a wave travels through to the behavior of the wave. Relate wave medium to its behavior. So the title in your book of this, yes, I did it too. I'm so sorry, Colin. I'm always telling you don't begin a sentence with the word so, and then I just did it twice. The title of the lesson in your book is The Behavior of Waves. I just got done telling you that I would prefer not to have to wear my mask during this because, why? Well, first of all, we all know the masks are kind of uncomfortable, but that's not what I'm talking about. Why else might I prefer not to wear the mask? Because it relates to this, Brett.
Because there's nothing blocking the signals.
Right, if I did not have my mask on, the sound waves would more easily travel from my mouth, number one, into your little ears, because that's who's learning it, and also into the microphone. And they can't get there as easy because I have a mask in the way, because the mask is made of a solid, right? And the waves, the mechanical waves emanating from my mouth behave differently when they encounter the mask than when they don't, right? What are they traveling through when they don't encounter the mask, right? We're very tempted to say, what? If you were being very specific, and maybe a month ago I asked that, what is the sound traveling through from me to you?
Molecules, atoms.
Yeah, that's you're thinking about it scientifically. If I just asked you on the street, I said, what's the sound traveling through? You might say
Nothing.
You might say nothing. Yeah, you might say air. You might say nothing though. People are tempted to say nothing. If I ask you, oh, I don't have one. I do have water in my cup. But if I did not have water in my cup, and I said, what's in here?
Nothing.
Y'all would say nothing, but that is not the case because all around us we live in a medium of air. So we call, let's define medium. We live in a medium of air. The sound waves that are emanating from my throat travel through a medium of air. When we say a medium, what does that mean?
What waves travel?
Yeah. It doesn't just have to be waves. In this case, we're talking about waves. But a medium is something that, yeah, it doesn't even have to be traveling, but something that supports another thing. But so, like for instance, if we're gonna make a definition scientifically here for a second, God bless you. But let me give you an example. A lot of times, if you don't take art, I know you don't because there's not an art teacher here. But sometimes in art, we talk about the medium that an art project was made in. So, for instance, you know the painting called The Last Supper by Galileo. It's a picture of Jesus and the disciples, and the medium of that painting is oil on canvas. It actually might be oil on panel. I don't know. The point of this is not art history, but the medium is oil, a type of paint on panel, right? So the way this art was made was by oil paint painted onto either a canvas or a panel, right? If you look at a collage, the medium is little chunks of paper glued to another piece of paper, right? You know what I'm talking about? So the medium is, I don't know, kind of a loose concept, but it's something through which we do another thing, right? So the medium here in science is let's say that's a good first word. The
Yes.
what? Help me define this. What is the medium? The medium is the okay.
Waves.
Waves, good. The way waves, so far.
The way waves.
The way waves. The way waves travel through
An object or
something. Let's just say something. The
Way waves.
something,
the way waves.
so the something that waves travel
The something.
through.
The something.
That's kind of a nice Dr. Seussish definition. I would never written it exactly like this.
The what thoughts were through.
I would say, instead of something, because I'm a science teacher, I might say what? What's a synonym for something that makes it sound?
Empty,
No, it doesn't have to be empty.
Object.
Object is not
something.
Sub.
Object.
Okay, think of the substance is what I was going to say. That's a science teacher thing to say. So I'm going to put the something that waves travel through. And really, we shouldn't end the sentence with a preposition either. So it should be the something through which waves travel, but this is fine, right? It's what the waves are traveling through. It's the thing through which the waves are traveling. What are some examples of, first of all, this word is singular, one medium. Can you think of what the plural might be?
Media.
Media. Have you heard of the media? What's that mean?
Snapchat.
Okay. So you've heard of social media. A social medium is a platform through which you can contact your social acquaintances, right? So Facebook is a social medium, right? Facebook and Snapchat together are social media. So when someone says social media, they mean the thing through which your communication in this case is traveling, right? When we talk about the media, right? When you hear the rancher at the grocery store talking about the media, they probably mean CNN, right? And a news medium, right? The way that people get the news. Because no one wakes up in the morning and their brain is full of news. They have to have a medium through which they get the news. The Crawford Clipper, that's a news medium, right? CNN is a news medium. Fox News is a news medium, right? The media, when they say that, they mean the thing through which people get their news. Does this word kind of make a little bit more sense to you now?
Yes.
So in science, we're talking about the something that waves travel through. What are some examples of media through which waves can travel? Let's list some. Water. What else?
Air.
Okay, what else? Mask.
Yeah,
mask.
What else? What's up?
Walls.
Walls. Whoops. Whoops. And as we already discussed, the
Hair.
waves behave differently when they're in different media.
Hair.
Right?
You're so
Okay,
blind.
hair. You mean like the hair on my head that's in front of my ears, but for a second I thought you just meant like a room full of hair, and I'm like, oh, that's kind of gross. Sorry.
Yeah, sorry.
Anyway, so here are some media, and are sound waves the only kind of waves that can travel through media? No. Light waves can travel through media, right? In fact, there are lights traveling through a medium right now. The light emanated by this LED light fixture are traveling through a medium to get to my eyes. What is it? Hair. Is that what you said? Yeah.
And then your
hair.
glasses, and then your...
But unlike sound, light can also travel through a different, well, we say medium, but what can light travel through that sound can't?
eyes.
Lenses.
No. What can light travel through that sound can't? Did I say that or did I say the other way around? I meant to say, what can light travel through that sound can't?
Was it?
You remember we talked about it in the last lesson?
Darkness.
No, it's not called darkness. Space. The what of space?
Oh, back.
Vacuum. So sound cannot travel through the vacuum, but light can travel through a vacuum. Okay.
I was
Yes.
something slightly related. So, what would be the said waves that are pushing the stone? Like, what would the wave be? Or would it?
So you're saying
what would
it's
it
terribly
be?
windy outside right now, and so maybe we could relate that wind to a wave, right?
Yeah. Or would that be a force?
It's a force, and there's not like a distinction. Forces can travel along in wave form, and waves can provide forces, so there doesn't have to be a distinction. But in this case, the wind is not a type of wave, because what do waves have to be? You remember? They have to do
A
what?
constant moving something.
Yeah, constant moving. We have a better word for constant moving. They must. What?
Accelerate.
No.
No.
Yeah, they must. They say it. They must repeat. Waves must repeat.
I was thinking of
And
repetition.
the wind is kind of going either constantly, or it's kind of like dying off and then going
Last
again.
night
But it's
was
not.
horrible.
It's not doing it in a repetitious pattern, right? If for whatever reason the wind was going 30 miles an hour for a minute and then 20 miles an hour for a minute and then 30, and that was a pattern that took place over a long period of time, then it would be like a wave. But right now the wind is not behaving. It's
Last night
behaving
was
as a wave.
pink.
Thank you for your contribution. So the medium through which a wave can travel is the thing, right? And we must know that, for instance, sound waves, any kind of waves, change the behavior of a wave. The media that it's traveling through changes the behavior of a wave. So for instance, back to my very first example, relating to this, why did I not want to wear my mask? Relating to this little sentence.
Sorry, sound doesn't have to travel through.
Right, because the mask is a different medium, the mask changes the behavior of the waves, right? In this case, what property of a wave is it probably going to decrease that I don't want it to?
Sound.
what do we call that of a sound? The
Volume?
volume, right? Which we're gonna talk about this right now. For sound waves, let's draw a little diagram of a sound wave. So you should know, sound waves are longitudinal. Whoops, longitudinal. Sound waves are longitudinal, meaning that the motion of the particles is what related to the energy?
Backward.
Yeah, we say, what? Remember the two words we used? In a transverse wave, the
Up and
matter
down.
moved perpendicular.
Up
In a
and-
longitudinal wave, it moves parallel. So the medium is moving parallel to the direction of motion. So for instance, let's draw a little sound wave here. What do we call that part of a sound wave? Or a longitudinal wave? What do we call the part where they're all stuck together?
Compression.
Compression. And we call the part where they're spread apart?
Rarefaction.
Rarefaction. Okay, so sound waves are longitudinal. So what's happening when I talk up here, give me a second, hold on. What's happening when I talk is that my vocal cords in my throat are going like this, and they're squishing the air between them together. They're making a compression.
What's the one that was spread apart?
Rarefaction.
Rarefaction.
So my vocal cords, when I do one sound with my voice, they squish together, they make a compression in the air in my throat, that comes out of my throat, into my mouth, and then it goes out to you guys, okay? Because there's a compression made, the air around it becomes a rarefaction. So this repetitious pattern of compression, rarefaction is called a sound wave, okay?
Yep.
The part of the wave that we call, the property of the wave that we call sound volume, right, when you turn up the volume on your headphones or whatever, that is what's called we know it, the amplitude of a wave. Amplitude of the sound wave is called the volume of the sound. And we didn't really talk about this, but for longitudinal waves, let me back up one second. How did we talk about amplitude for transverse waves? What was the amplitude of a transverse wave?
Sorry, what was the question?
How did we measure the amplitude of a transverse wave? Remember, transverse waves looked like this. The amplitude was what?
Oh, the
The
distance.
distance between the trough and the
distance between the crest.
Right. This was the amplitude for a transverse wave. In longitudinal waves, the amplitude is how compressed the compressions are, or how spread apart the rarefactions are. So it's kind of hard to draw up here, but if instead of being like that one, I drew it again like this. And now see, compared to this one, the rarefactions are a little bit closer together, and the compressions are a little bit farther apart. See, there's less difference, basically. There's less difference between the compressions and rarefactions. This is low amplitude. This one would be high amplitude, right? So effectively, if I yell,
Oh my god!
right? If I yell, my vocal cords make. Sorry. If I yell, my vocal cords get tighter together. They make a much bigger. Let's take a second to calm down. If I yell, listen. If I yell, my vocal cords make a much stronger compression, right? And so the compression gets tighter, meaning the rarefaction gets further apart. So high amplitude for sound. High amplitude means high what? Maybe you'll never forget. High volume.
Compression.
High volume. And if I just whisper, it changes the compression less, right? Colton.
So, alright, it just
Let's start over.
from high to low to high. Okay, so then if it kept doing that repeatedly,
That would count as a wave. That would count as a wave because it would be repetition.
Alright.
So for longitudinal waves, high amplitude is when there's a bigger difference between compression and rarefaction, and low amplitude is when there's less of a difference. There's another thing that we can talk about, that we can relate the property of a wave to something that we notice about sound. What's another property of a wave? We had amplitude. What's another property of waves in general?
The wavelength.
The weight.
The wavelength, which is related to wavelength, which was lambda. Lambda,
Is it lambda or
Lambda and
and what was the other thing?
1 second.
F? Like the F thing.
F
Yep,
or what?
frequency.
Frequency.
Frequency. So for sound waves, high pitch is high frequency, and low pitch is low frequency, okay? So we're gonna write that for frequency. High pitch, what we call pitch in music or in sound science, is the frequency. Oops, I should have made that an equal sign. High frequency. And how could we, using our little drawing here, how could we draw a higher frequency? What would be true of the compressions and
You
rarefaction?
can make it
They'd be what? One compression compared to another would be,
What?
like these two compressions would be how different if it was higher pitch?
Well, they'd be,
It would
they'd be
be
close.
one-
Closer together, closer together. So we'd have a compression here, rarefaction, compression here, rarefaction. This would be a higher pitch sound than this, okay? So pitch is frequency, amplitude is volume. Remember those two things. Maybe just write that very simply in your notes. Pitch equals frequency, volume equals amplitude. So what we're doing is relating properties of sound specifically to properties of waves in general.
Pitch equals frequency.
Pitch is frequency,
and then what?
Amplitude is.
and this volume is amplitude. So when they take a song, oh, don't start your sentences with "so." What is wrong with me? I'm sorry. Well, I got the disease from you. When, let me start over.
So
When they switch a song from being by Kesha or who? I don't know. When the Chipmunks, I'm trying to get to you. When the Chipmunks sing a song, you know Alvin and the Chipmunks?
Yeah.
Okay, first of all, number one, I hate it. Number two, what they do is they increase this. They increase the frequency of the sound to make it higher pitched, right? Don't do the voice. I'll
Yeah,
drop out. What?
There's
Sorry.
this-
No.
There's this one guy that can make, they just like they have like a disc, and like just any kind of disc. And they play a song, and they just like increase the pitch by a lot, and it sounds like Alvin.
Yeah, exactly. So, because all it is frequency of the sound is the pitch. So to make the sound higher pitched, we increase the frequency. How if we needed, which we don't, but if we needed the Alvin and the Chipmunk song to sound louder, how would we do that? We would increase the, which would also increase the what? Amplitude. Good. Okay, so now we got to talk about, you have questions about this. So we talked about the medium of sound waves. We talked about how sound waves in general behave as far as compressions and rarefactions. We talked about the frequency and volume of sound. Do you have questions about any of this on the board right now? Is it okay if I erase it? You're done writing this stuff down? Did you write down, Colton? All of it?
Yeah.
You understand that you're responsible for the information I put on the board, right? Like this is the stuff that will be on your test. I hope you find that it's helpful for me to talk about this with you. Yes?
Yes.
Yes.
We're going to move on now. We're going to talk about behaviors of sound waves. Sorry, not just sound waves, behaviors of waves. So we said that, oh my goodness. We said that changing media changes the behavior of a sound wave. Well, these are the ways that sound waves can behave when they interact with a new medium. Waves, sound, no, not just sound waves. We're talking about all kinds of waves. Waves can change behavior when interacting. What's the word interact mean?
Does that say waves?
Waves can change behavior when interacting. What's interacting mean? If I were to interact with Angie, what would that mean?
Touch.
Touch, talk to. Somehow I would be performing some action with Angie, right? Inter, between two things, acting. So, waves can change behavior when interacting with a new medium. Let's use the wall as an example. This is going to be a nice drawing. Wall.
Yes.
Who wants to be in the drawing?
I want you,
Jaden.
Cyrus. Me.
Fat man over here. Ouch. I hurt my.
You aren't fat, sorry.
God looks like Pac-Man.
Okay,
I made a Pac-Man.
Jaden.
It was hot.
Why do you think okay, so why did I draw Jaden's head like that, first of all?
Because
Just kidding. Smack him.
Okay, because of his hair, but also because of he's going to be doing what,
We're
probably?
running
Killing
out.
someone.
No.
It looks like
Yelling.
yelling.
Yeah, he's going to be making a noise. Okay, so the sound waves, I'm going to represent, the sound waves are going to be,
Yeah,
I'm going to, shh, I'm going to draw the compressions as lines, and the rarefactions will be the distance between the lines. So he's making a sound wave, which emanates forth from his mouth. And it can do one of three things when it interacts with the wall. 1, 2, 3. We're going to write them each, and we're going to describe them. What do you think? What can happen when those sound waves interact with the wall?
It bounces.
Okay, bounce back. And we call that reflect.
Reflect, yeah.
Reflect equals bounce back. There's a special word for this when it's sound waves. What do we call it? We just said it. Before the video, I mean. What do we call it when a sound wave bounces back?
Echo.
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 We'll put echo for sound. We obviously don't call it that when it's light. What do we call it when it's light? If the light waves bounce back, we call that a reflection. Yeah, which is related to this word, obviously. So they can bounce back. I'm going to do that purple. Or sorry, that's not purple, that's blue. So if they bounce back, that's called an echo, right? And that's one thing that can happen. What's another thing that can happen?
Can't they go through the wall?
Yeah, through the wall. And we call that transmission. Transmission. We're going to do that one in orange. So some of the sound waves are going to go through the wall. What do you think is going to happen to them as they go through the wall, though? First of all, they spread out.
Yeah.
Waves always do that. What else do they do?
Slow down.
Slow down.
Probably not slow down, but that would make it lower pitched, but they probably do
Quieter.
get quieter. They probably change their amplitude, right? They change the volume. Okay, so they can transmit. And then what's the third thing? If any wave doesn't do one of these two, what's it going to do?
Disappear.
Absorb. Absorption.
Oh, my back.
Sorry, I didn't define transmission. Let's define transmission together. What is it doing?
Going through the wall.
Going through.
Going through.
And absorption? Well, we know what absorption means, right? It's being
It
absorbed.
absorbs.
It's
It just,
It absorbs. It's just
it hits the
absorbed.
wall and it just stays.
yeah. We can say it. Well, I don't know. Absorption is fairly. We'll just call it absorption. You know what absorption means. And so for absorption, we're just going to say there. It stops in the middle of the wall, right?
Absorption.
Okay. Now listen. This is for sound waves. Do you think this is true for all waves?
No.
Say it again.
Yes.
Yeah. it is. So let's do it. What's another kind of wave we could do this with? Sound wave. What's another easy one we could do with? Light waves. So we said, if light waves reflect, we call that
Reflection.
a reflection, like a mirror, right?
Yeah.
It's not only a mirror, because there's also something called diffuse reflection, where like, can you see this wall?
Yeah.
Yeah. Is the wall a mirror? No.
Yeah. it looks
No, Cyrus. The wall is not a mirror, but it's still reflecting light, right? Because the wall is not emitting its own light. The only way you can see the light is that the light's coming out of this light fixture, bouncing off the wall, bouncing into your eyeballs, which are absorbing. So the light is reflecting off the wall. Okay, if light were transmitted, what do you think transmits light? What's an object in this room that transmits light?
The lights.
The little plastic panel over the light. What else?
Your board.
Yeah.
Board.
Oh, that
maybe like the front of the board transmits light because there's lights behind it and the front is clear. Your eyes transmit light. What else? Say it again. The window transmits light. And then, if light is absorbed, what absorbs light? The wall absorbs a little bit, right? The wall reflects some and absorbs some. Your skin reflects some and absorbs some. People reflect some and absorb some. Everything, in fact, for sound, light, whatever, all objects, anytime it changes medium, there's some combination of these. Do you think, through the window, do you think all the light is transmitted?
No.
No, some of it's reflected. Sometimes you can see yourself in the window, right? Like you walk by a car and you can see yourself in that window. Because not all the light is transmitted. Some of it is reflected. Okay? Do you think all sound is absorbed when we talk through that wall?
No.
No, we can still hear it on the other side. For every time that a wave changes medium, it's a combination of these three things. Some combination of these. Maybe it's 60% reflected, 20% transmitted, and 20% absorbed. But some combination of these three things happen for every wave going to a new medium. Questions about that?
I created a beautiful image.
That's very nice. Questions about anything that we've talked about today?